isotope. Let's look onto the periodic table again. Now let's pay attention to proton. What's proton? Proton, positive proton. Positive proton. Proton is important because the proton is determining what atom you are. Proton determining what atom you are. For example, you look on this 6. 6 must be carbon. So 6 proton means you are carbon. 7, you are nitrogen. 7 can't be anything else but nitrogen. 8, oxygen. So proton cannot change. You change the number of proton, you change to another element. So proton cannot change. Proton determine what element you are. And then how about neutron? Neutron different. Neutron job is only to stop the positive proton repulsion. Because proton and the proton, they will repel each other because they both positive. So I need to have this white dot that is the neutron so that to stop the repulsion happening. So this is the job of neutron. Then what is isotope? Isotope talking about you have the same number of proton because the number proton, positive proton must be the same. You change proton, you become different element. But how about neutron? Yes, neutron you can afford to be vary. Example, I have 3 types of carbon. They all have 6. The first type, you have 6 proton and 6 neutron. The next one, you have 7 neutron. The next one, you have 8 neutron. So in these 3 examples, they all are carbon because you have 6 proton, but you have extra neutron. And this extra neutron, different number of neutron, we call it isotope. Isotope, is it something rare? No, actually on this table, this is an isotope table. You see on the bottom number, all the bottom number are to indicate isotope. Let's take some example. Magnesium, they are 12. So 12 proton must be magnesium. But you can have a 24, 25, or 26. That means you can have extra neutron. So most of them will be the 24. But some 25 and some even magnesium 26. So this is called the isotope. So you got 3 different isotopes. Boron have 2 isotopes. You have the 10, boron 10. You also have the boron 11. Carbon, you have a carbon 12 as the majority, and you have tiny bit of a carbon 13. They are the isotope. So, as we learn, the isotope means they will have an extra neutron. When the time you have extra neutron, chemical reaction have no difference. In chemical reaction, isotope have no difference. But only different is the weight measurement will be different. The weight measurement will be different. And following, I show you. On the periodic table, If you look onto the mass number, you take hydrogen 1.008. What is this 0.008? And what is this 0.941? What is this 0.99? How come you have so many decimal places? And here I explain. Now I take chlorine as example. How come you got this 35.45? What's 0.45 mean? Now I explain. The naturally occurring chlorine consists of 75% chlorine 35 and 25% of chlorine 37. So that is the isotope. So you have some isotope. And so how do I get the measurement of the weight? I just do it by averaging. Here's follow. The average relative atomic mass is 75%. So I put 75 times 35 plus 25 times 37 and divide 100. So I got 35.5. And that is what this periodic table decimal place about. That is what is on the periodic table of all these decimal place in atomic mass about. Thank you.